Thanks, Sean. Thank you for having me as well. I'm here to talk about something that I've been working on for the past year, on and off, and hopefully it will help other people get their testing with end-to-end testing a little bit abolished and not rely on it as much, but we'll see. A little bit about myself. I work with ADBD Apps crew. That's enough about me. Into the presentation. So what I am planning on presenting to you today is how we are normally verifying the integration between APIs, what the actual problem there might be, what stems from it, what we are dealing with, and then go into what contract testing is, and hopefully show a non-breaking demo. But first, let's be honest, programming is really cool when you're programming alone, but if somebody is watching you, it's not going exactly to plan, so heads up. The normal API integration modus operandi, how we're normally dealing with, is quite a lengthy process, and we've been burned quite a lot in the past. And it goes something like this. In order for us to test the flow through the systems, we need all the systems involved up and running, right? For us to see data request going into, and in this case, into API gateway to hit something in the back end and then come back. If we want to test this, we need all of the systems up and running in a end-to-end ready test environment, which is okay, but that is generally slow because we need to wait for everyone to deploy. We need to all pretty much work on the same feature at the same time and deploy at the same time. All of these microservices here, as an example, need to be deployed correctly, configured correctly. Even if they're not final versions of the software, we still need a version of them that integrate between each other. So we at the end, because we mostly on the mobile apps work on the clients, only then we can see if our thing works. This is also very fragile because if one of these systems is down or not up to date or deployed correctly, we don't get to test our stuff at the end of the chain. Then comes in data management. If we are setting up our end-to-end tests with some reliance on data, we're pretty much sure this will break next week when dates change or when perhaps amounts change that we hard-coded to verify and so on. So that's quite painful to go through and see where it's actually breaking. We have test environment management in here because we need this environment available for us to run the tests. And the more systems we have involved, the more people we need in there as well to help us out and debug where things are breaking. Coverage, how do we cover this? Hard. And of course, we need to, like I said, we need all of it deployed and pretty much at the same time. And we're not necessarily all developing on the same feature at the same time, especially in big corporations. So why is this not ideal? We are coupling the release and our tests. In order for us to verify that we are integrated with the backend systems, we need everything coupled up and deployed at the same time. We are spending a lot of time on managing environments and being idle, trying to figure out what's happening, what could be breaking if things break and so on, instead of developing. This means that because we have too many systems, we have a slower pipeline leading to batching of releases. And with this batching, more failures and defects are exposed and introduced. We have deployment risks. Again, things can go wrong when we deploy. We might not configure things correctly, and we need to wait again. We introduce separate testing teams that might not understand what is implemented in the backend systems, what is possible to test, what needs to be tested, and what is an actual bug or not. We end up with Release Manager to help with the teams, the new teams, and everything else to be managed, to govern the entire process, to gatekeep releases and so on. And lots of times when we are seeing the end-to-end tests being done, lots of ad hoc change requests are put in just in order to verify that end-to-end test comes through, which is again not great, and we are accumulating debt. But all of this would be okay if we were testing a monolith, but obviously we're all working on, well, most of us probably are working on clients that are integrating with a lot of microservices in the backend. So this approach does not work for that. How does our integration process and API development normally work? Well, we get together, we start talking about what we need, what we need to expose, and we talk with our backend developers to prepare a Swagger or something, define how it's going to be behaving, what we're going to be, and on the client side, what we're going to be developing against, and what the provider will be providing us in the end. Hopefully this is all fairly accurate. Normally it's not, and hopefully, and in cases when backend relies on automated Swagger generation, we can't really get the accurate Swagger up front, so it's not pretty reliable. We go on and implement and deploy the provider, so the service. We test using our own mocks and fixtures, well, on the provider side, which is good. Tests the provider, nothing wrong there, right? But on the other end, we implement and deploy the consumer that also has its own mocks and fixtures that eventually they do drift apart and they do not match and sync with the backend fixtures anymore. Of course, the software is never finished. We do improvements. We test against updated mocks and fixtures. We deploy the changes. Hopefully nothing breaks, but we never can tell, can we, until we are in a integrated environment. Well, lots of times we end up with a fire that we need to put out, figuring out where the data has changed, what the configuration was missed or something like that, and we're just dealing with repercussions. That's where contract testing can come in. Specifically consumer-driven contract testing. It's a technique for testing an integration point by checking each application in isolation. With this, we're trying to remove the need to deploy all of the systems, all of the integrated systems in the whole ecosystem to be up and running, and only test the boundaries of our client, of our consumer, with the next provider in line. We can do that with defining a contract and sharing that contract between the consumer and a provider. So let's look at this environment that we've seen before. Instead of relying on data and testing the whole flow through, because honestly, we don't necessarily care how microservice B and C is communicating and if it's integrating correctly or what's flowing between them, if we're only working between iOS system and the API gateway, right? So we can and should be able to split this up into isolated integration points. Define how those integration points look like, what are the required inputs and outputs, what are the expectations of the communication, and based on that, test it, hopefully locally. The benefits of this is it's simpler because we, as let's say iOS developers, only care about our integration towards the API gateway. We don't have to necessarily deploy, and we only test that point, nothing else. We don't have to have dedicated test environments. We run it on a dev machine. We'll see how we do that later. And we have fast feedback as well for the responsibilities on our side as consumers. Instead of waiting for everyone else to do everything they need to do in order for us to test our integration point that is completely detached from anything else. In this case, we can also have tests to scale linearly. We don't have to rely on all of the other systems to do everything else and put in tests for them. And we can deploy services independently, given the contract is not broken. So that what that means is if we would have microservice B and iOS app there talk to each other, or API gateway, if everything is fine, even though the backends are still working on another version, new version or so, and we can still independently deploy if we are not breaking the version that we are integrating with. So why consumer-driven contract testing is it helps us and provider team develop only the feature that consumer needs. So normally when we talk about how the provider would expose APIs, they go in and start working on a lot of different functionalities, exposing different data sets and objects. Instead of going ahead and exposing things and working on things that are not needed by their consumers, consumer only tell the provider through a contract what the consumer needs, and that's only the thing that the provider can work on instead of spending more resources and time. With this, we can catch situations when a service provider and its consumer implementations become incompatible. So that's the point on the fixtures drift. As soon as we start adding more features into the APIs, we should be able to test them and verify them quickly. We can catch it on developer's machine. Instead of going and deploying everything and waiting for all the systems to deploy, be ready to run a simple test, we can catch this running on a local machine before even deploying a breaking change. With this, we can have independent, but yet still coordinate integration testing for both consumers and providers. When we do not do contract testing itself, we normally use fixtures to only test how we consume the API responses, but not necessarily what is actually sent out of our environment. With PACT and PactSwift, we can do that as well. We can have a shared understanding defined in a common document, so a contract, and we share that document and it's actually testable. Using this contract, we replay requests and play responses on which we can assert our test cases. We can also reveal unused interfaces. On the provider side, for instance, if they have multiple clients and only require, through contracts, a subset of functionality, that unused functionality can be dropped, deprecated. We don't have to worry about it. Less bugs, less code. It's always good. And because all of the contracts hold the information who the parties involved are, we know which clients, which interactions we are breaking and could be breaking before we deploy, and we can inform those involved parties at breaking changes in coming in, and they can fix it before deploying. Consumers can develop, so for instance, iOS app developers can develop against an API actually running the network calls and testing that before APIs are deployed. We can do that with stubs, but this one's actually shared. So the providers know which consumers to notify about must-have breaking changes, thing that I was mentioning before. We can improve, and that has been shown with where PACT has been introduced, that communication between front-end and back-end teams, because there were less breaking changes or surprise changes, surprise breakages. Teams started talking to each other and working together on APIs and letting other teams know that things will be breaking before they deploy breaking changes. The PACT broker in this whole thing is another really great thing that gives us the ability to map the relationships between our services and consumers, and also tracks all of the versions of the contracts and verification results for them. I'll mention that later on as well. There's probably a lot more benefits of consumer-driven contract testing as well. These are the major ones. Grabbing that in, it's like it just lets us sleep at night, assured that we don't release something that will break through the night. What is PACT? Essentially, PACT is a specification that defines the contract structure. It defines what goes in and how it looks like, what is required, so the implementations of them know how to talk to each other, how to replay requests and how to replay responses. It's implemented in more than 10 programming languages, and it started at REA in 2013 when they had a problem with changing microservices, and this was their solution to figure out how to reduce their reliance on the end-to-end testing environments. The contract would look something like this. It includes the name of a consumer and provider, so the relevant parties, and it has a set of all the interactions that the consumer is expecting the provider to have available. It provides us the description of the states, description of the request, of the interaction. It defines what the required state for this interaction is, so we get expected tests on the provider side. It defines a request that is expected to be sent by the consumer, and this one is then replayed on the provider side. And it defines the response and how the mock service responds, and with a few generators or matching rules, how the verification needs to be carried out. We start off, so we have consumer and provider, we have our unit test, and the first thing with the consumer-driven contract testing is we define our unit test and we test our behavior against provider mocks. As a consumer, we define that behavior in the mock and record it in a contract. Contract is shared with the provider, be it through a PACT broker or handballed through a folder or somehow. PACT broker is definitely better, but it can be emailed as well. The contract then replays those requests that are captured by the consumer to the provider when it's running, either in tests or on the real thing, and verifies that all of the requests that the consumer is expecting have a response that the consumer is expecting as well. And both of these can be tested in isolation. They don't need to be on the same machine. They don't need to be in the SIT environment or wherever. They are on developers' machines or on CI. A flow of implementing a new feature can be, as an overview, can be done like this. You build a new feature that talks to the backend API. We run the unit tests. We generate a contract, and that is shared to PACT broker. With a tool called Can I Deploy, we check whether the provider has verified this new contract. And in this case, no, because it's a new feature, it's a brand new contract. We're not really allowed, or we shouldn't be deploying with confidence because we don't know whether the provider is doing what we are asking them to do. So we stop there, but nothing is actually stopping us. We can still ignore it, to be honest. On the provider side, a webhook might be set up that would notify the provider to run tests with the new contract. Tests are run, the verification results are published back to the PACT broker, and nothing, in this case, nothing breaks. Fantastic. We can go and deploy the provider, and through a PACT broker, we can notify the consumer that it has been verified and we can deploy it. For instance, in a PR merge, we can run the test again. We tag the version of it. We publish the contract again to PACT broker, which one was deployed. Let's say it was version 1.2. Can I deploy? Ask again the PACT broker. Yep, they verified it. Everything's hunky-dory. We deploy. Nothing should break in production nor sit. Or a new feature on the provider side is implemented, refactor or something is happening either way. Build, run the test, grab the latest contract that the client is defined as a release, verify the results, share the results back to PACT broker. Can I deploy because nothing has broken? Yep, provider can deploy changes without, or refactor things without breaking the flow. Cool. Let's jump into our little demo, and I will show you that I have two very simple projects. One is an animal service provider built with Vapor 4. It's very bad because it doesn't follow conventions, and that's intentional. I also have a very simple animal client. There. Animal client that makes simple requests for animal object and species object. I am going to run this animal service. Is it running? Not yet. It's running on localhost 8080. Yep. And I am going to ask for all the animals. I have no animals because I did not seed the database. Nope. All species. I have species, but I don't have animals. I'm going to stop this. And redo. I'm using Docker for Postgres database. Start, reset it. Seed. There we go. I'm going to start this service again. Hopefully I get a Mary, an alligator Mary as an animal. I can create an animal. I can also get one animal, specific one. Again, Mary. I can get all the species of this animal. It works, right? Cool. On the client side, what I need to do in order to create a contract is literally just bring in a framework called PactSwift. That's fine. I'm going to add it to the test target because that's the only place I care about it. And this is how a PACT test in iOS looks like. We define a mock service. We define the expectations for this specific path, and we say define what this interaction will be named, so the provider side can look it up and see what's happening. And on PACT Broker, we can list them out as well, and straight away from the top, we can see what's expected, what's going to happen. We define or promise what our client will send out. With this test, I define that I'm going to be sending a GET request to Path API animals. And when this happens, when the API gets this request, I expect it to respond with 200 and a list of animals with a minimum amount of 0 elements. I run the test of my animal client. I pass it in my base URL. I pass it my method that I've set here and my animals endpoint that I defined down here. So it always should go localhost, whatever it's going to be, API, animals, path query, and so on. Super stupid, but it works. Also, I defined that all of the contracts will be written in my project directory temp folder. Let's see what's happening there. Animal client, temp, cool, remove animal client, done. I will run this. It should pass. That succeeded. Should have started the simulator before, but that's okay. Testing, still testing. There we go. It's going to run it. It's going to shoot off a actual request to localhost, which is an in process server that is provided by PactSwift. Sean, I need a better computer. There you go. Animal client. Test passed because this was actually sent out and this was as a response, and I tested it here as well that the Mary was the thing that was passed back. And here I have a animal client JSON contract. I'm going to share this. I'm going to copy this into shared shared contracts. I don't know how to computer. There we go. And I'm going to jump onto my provider service, and I'm going to be running a PACT verifier CLI directory shared contracts. This is the verifier that takes the contract and replaces that interaction to a port 8080, which is my server running now. Everything is fantastic. Everything is cool. What my client was expecting, the provider is providing. Cool. All right, now let's move on to more development and develop more tests. Something complained somewhere. There we go. Cool. I have many more tests now for different requests. going to animals, actually going for species and so on. And I'm going to run this. No, I won't. I'm going to restart this. I'm going to rerun the test. Now it's going to add all of these interactions into the test contract. What they do is really just defining different interactions, get requests, post requests, also get, there we go, there's a post as well, that it defines that when I call a post on species the same with this header, this body will be responded back with 201 and so on. So my test on the client side passed. I'm going to copy it again. I'm going to go onto the provider side in the service, and I'm going to test them again. Let's just see if it's running. No. Starting on, yep, cool. Oh, no, it's not integrating correctly. With this, the request for alligator Mary returns a response which has a status of code 200 failed. And at the bottom, I can also see why it failed. It did receive a request, but the response was 404. Why would that be? Because the provider is not exposing a animals API, but animal. All right, let's change this. Better. Stop it. Come on. There we go. Starting again. Cool. Running. Run verification again. Yeah, still nothing. See, that's what I said at the beginning. Did it run properly? No, still not running. Fatal error. Address already in use. Okay. 6807. There we go. Start again. When I stopped it before, apparently it did not release the port. Cool. Now it did. Run the verification again. Okay, cool. The list Mary is returned okay, but we still have a problem where a list of species does not return the correct body. We have 0 length, but the client is expecting at least one object to be returned. So what this gives us is that communication between the teams to go back and, hey guys, you're asking for something a bit ridiculous, because we can have a category that has 0 objects to return. So you are asking for something that cannot be necessarily good. All right, I go back to the client. I change the contract. I run it again. I update the contract. Running. Mine will still be okay because the tests that I define here, when a mock provider will respond with 1 object, and I will test against that. But as a verification, like the contract tells the verifier, the provider, that you can also send 0 responses back. All right, let's share the, oh, where am I? cd temp, copy animal to that. Cool, I've updated it, run it again. Everything is hunky-dory. We are integrated without having an integrated environment up and running outside of our local development. Happy days. This is obviously only on my developer machine, but with the CI and automation and everything in place, we would share this through a PACT broker and automate all of this pretty much to the T, and it would allow us to catch all these breaking changes or not meeting the contracts. I've been working on this PactSwift framework that does not require any extra installation of mock servers or anything like that for the past year, mostly during Tour de France. But what's coming next is verification for the provider at the unit level testing, not like demoing now with running the actual thing. Finding and fixing bugs, because this is a V3 and it's using a shared Rust code for mock server. And there's a PACT Specification V4 coming out eventually, and I need to start thinking about that soon. Thank you for tuning in. You can find more about this at GitHub Surfer PactSwift. That might be moving on to PACT Foundation soon, or someone else digging into PACT, go to PACT.io. And if you're keen on developing a PACT implementation, you can start looking at PACT Foundation, PACT reference. I'll be around. Lurking in Melbourne CocoaHeads Slack. Hit me up. I'll answer any questions or just raise issues in the repo and I'll get on it. Thank you. Back to you guys. Sean.